Good morning and welcome you all. So let's start our today's class. In last class, we understand about basics of the networking and relating with that classes. Now we'll understand different communication protocols and the communication protocols that are used in Industry 4.0. To before begin this thing, so I want to give you some overview that are generally helps you to understand the protocols. The protocols are several protocols are available. I mean numerous in numbers of protocols are there. Huge number of protocols are there available in the market for the communication for the network. But there are some specific protocol which are used in the industry. Those things I will discuss in this class. And overall, first I want to give you an idea that how the protocols, in which basis the protocol generated, and what is the key idea behind it. Okay, so let's start the class. So protocols is the communication scheme which will have the following things in common. That is source or sender, destination or receiver, channel or medium. So protocols means kind of rules that governs all members of communications. So as you may heard that the protocols regarding chief minister, protocols for prime minister and the presidents, the protocols are the rules that should be maintained for the communication for kind of system. That is the rules for a system to communicate between. So in our industry, the protocols for the communication is to the some rules which governs the method of communication. Fine. Now now let's understand if there are no protocol. For example, there are two people are want to communicate with each other. So if there is no protocol, for example, this is a people from China and this one is people from India. So see, these people don't know Hindi, and this is this people, the Indian, that is he can't speak in Chinese, or didn't know the Chinese. So what happened? Although they are speaking some meaningful words, but they can't understand each other. Okay, that is the case. That is the case number one. In case number two, for example, if these people, both people know Hindi, but one people speak very fast, and these people can understand the that kind of space of fast communication. So what happened? These people also can't understand the thing what is talking, what is saying by these people. So therefore, the some things you have to maintain some space. You have to maintain the same kind of language you have to maintain. So we'll also see what are the things we have to maintain in proceeding sections. So this is the basic basic things, basic idea behind any protocols. Okay, it protocols may be for the industry, protocols may be the mobile communication. There are different type of protocols are there for each and every specific communication. But in this class, I want to give you the idea of the protocols, why the protocols is needed, the need of the protocols for a communication. Then we will directly go to the industry related communication protocols. The protocols is, as I told you, it's a rule. It's a set of rules that govern the data communication. And protocol determines what is communicated, how it is communicated, and when it is communicated. Okay. Now, the protocols are necessary for human communication, as I told you. That is, there is a sender or receiver. So speed of timing of delivery, as I told you, that should be a common language. There should be a common language, and there is a identified as sender or receiver. Who is sender, who is receiver? Because if they both are talking at the same time, so no one can understand what the other is talking. So therefore, the you have to at one time you have to identify who is sender and who is receiver. Fine. Then the confirmation or the acknowledgement of the requirement. Okay, so suppose for example there is a barrier between them. So if this people talks to this one, so he after he completed his sentence, so these people have to understand by these people have to confirm to these people that he got his message or not. So this is required for the for long distance communication. So you will see now the protocols used in the network communication are defined as the different types. This is the very basic idea behind any communication. That is, first is message encoding, message formatting, message timing, message size, and message delivery options. Okay. Now, what are the elements of the protocol? These are the elements of the protocol. Fine. So, what is message encoding? So, from a message, you can see that if this is a message source, then it will encode, the signal will encode, then transmit. Then there is a transmission medium, it may be wireless or wired. Then there is a receiver, and a decoder will decode the signal, and you will get the message destination. So this is very simple, very basic things and all the protocol depends, and the very basic architecture of any protocol will be this. Now the message formatting. Message formatting, it is encapsulate the information to identify the sender and the receiver. So that is something is called the encryption or decryption. Okay. Now the message size. So for example, is when human talks, they break long messages into the smaller parts or sentences. So therefore, if you want to send long messages, so you must broken into smaller pieces to travel across a network. Fine. Now the message timing. So that is the message timing or flow control. Something called response. Also, this is also the response time. How long this machine have to wait to receive a signal from this machine. So that is there is a response timer, because this machine have to work something anything any other work. So there is a defined time. So you have to wait for this time. Within this time, if some messages messages come, so you can consider this, otherwise you may go for another one. Okay. Then there is another term, elements, that is message delivery option. It may be unicast, it may be multicast, or it may be broadcast. What does it mean? It means that very simple. So it's a kind of theory part, so you can easily understand. If you memorize it, it is okay, but you can visualize it also. Unicast means there is a source, and these particular computers are the destination. So this is source and this is the gateway. So unicast means this source can only send to this one particular receiver. So that is called as the unicast. Multicast means if the more than one but not many. So that means maybe two or maybe 10, not 100. So that is multicast. So this source, for example, can this particular source can send the data to these two computers. So that is called as the multicast communication. Now, what is broadcast? The broadcast means one to many. Many means in numbers. It doesn't matter how many are there, but broadcast means this source can send anyone. So like TV broadcasting. So that is the kind of message delivery options are followed in nowadays. Now come to the peculiar kind of protocols which are commonly used in our automation industry. So these are Profinet, Profibus, Modbus, as interface protocol, HART protocol, Fieldbus protocol, DeviceNet protocol, and CAN protocol. the mostly used protocols are field bus protocol. HART is nowadays, I think, it is I mean obsolete, but most of the industry also use this. But the I mean advanced kind of protocols, these are field bus, Profinet, Profibus, Modbus, CAN, device. So I think our time will not permit, although we are going to discuss, I'm going to discuss some of these protocols in detail. So let's start with the field bus protocol. So field bus isn't really one thing, but more of the collection of the things. Field bus is a group of protocols that are used in the industrial arena. The field bus protocols have been standardized as IEC 61158. Basically, field bus works on a network that permits various topologies. What are the topologies? You may have heard, if some people are from the networking division, they may have, I mean, they may be familiar with the different type of networks, topologies, that is string, branch, star, daisy chain. I don't want to discuss in detail because there is very basic things, and I think you can easily search in on the internet also. So, but for the time being, for this class, I just want to give you the protocols which are used in the industry. So prior to field bus, industrial controller are generally connect to the PLC, as we know that, and using which cable, that is RS232 cable. There is a serial communication. As you know, serial communication allowed only two devices to communicate at a time, but whereas nowadays the field bus connections are more closely compared to the typical Ethernet connections, where you can connect multiple devices to a single point of connection. So this is a single point of connection. You can connect multiple devices. That means multiple field devices. So, however, field bus is not a connection type, but instead a description used to indicate a group of protocol. So there are different group of protocols are there. So field bus is actually indicate a group of protocols. So these protocols are maybe control net, that is in the Allen Bradley family, Modbus, Profibus, EtherCAT, HART, CIP, and many more. Now, come to the primary benefit of the field bus is that this field bus is connected to the field devices. For instance, if you consider, we have several field devices and okay, let's see this. So we have several field devices connected, and we want to connect it to with the Allen Bradley PLC. And the devices may be sensors, motors, lamps, switches. So these devices are primarily connected to a I/O data block. So this is the I/O data block, which is then connected to the field distribution devices. Then this is called the field distribution devices. Some part of it, this field distribution devices. Then finally connected back to the controller, that is PLC controller over here. The connection to the field bus components this scheme may vary depending on the field bus protocol that you are using. Okay, as I told you, the field bus means there are different type of protocols. Okay, that may be Modbus, that may be Profinet, Profibus, and many more. And the connection scheme, as I told you, the connection scheme is mainly depend on the field bus protocol that are used. So this type of field bus device connection saves on wiring runs that would have to go all the way back to the controller. So main thing is that it saves the wirings runs. As you can see in this slide, that this type of device wiring would have many benefits when the distance is an issue. As you can imagine, your controller system will need to have communicate with the modules that will be able to establish communication with the field devices. That modules may be Allen Bradley, maybe Siemens, maybe Schneider Electric. In case of control net, you would need a control net module. Profibus would need a Profibus module. And so there is not to say that every protocol is dedicated to a particular manufacturer and must connect to proprietary controller. For instance, Profibus is mainly widely used protocol that can connect to. I will give you the details about the Profibus. So Profibus is mostly most widely used protocol that can connect to Allen Bradley, Siemens, as I told you, Modicon, etc. The same applies to the universal protocol of Modbus. However, some protocols do not play well with each other. For example, Allen Bradley and the Siemens. On the other hand, control net is an example that can't indicate with the Siemens processor. Okay. With this information, you can see that there should be a great care taken when you are designing your plant control system, including the communication network, and especially the device layer if considering the field bus devices. So you have to first make a list of the compatibility of devices, that this device makes with Siemens, this device performs with Allen Bradley, or maybe with the Schneiders. So you have to make a list of the compatible devices as well as the communication protocols, so such that you can easily run all the devices, that is the field devices, as well as the PLC at the same time, because you need a communication between them. In the real world of the device to device automation communication, a dialogue or conversation between, if you come to this slide, that this communication between different device occurs systematically. In many cases, over different type of communication networks and in different languages. But the depending on process automation equipment manufacturer, a specific or proprietary language is used, or maybe language that that is commonly open to industry. Okay, so it is kind of open protocols. So therefore they can be adopted by different manufacturers to easily integrate their products in the market. Okay. So and open protocols means, so this is a kind of considering as a open protocol. So this open protocol means the specification are published and may be used by anyone freely or by license. Not only this, open protocols are usually backed by the combination of the corporations. That may be user group, that may be government, that may be professional society. The providers, the provider, this kind of system provides you much wider choice of devices or systems that can be utilized to meet specific application. Now come to the advantage of this open protocol, that includes support by multiple manufacturers. that also that maybe that manufacturer maybe software vendors, that some other vendors can install or service the organization, and there may be different active community groups which can support this kind of open protocols. So one of the most common automation communication protocol in connecting industrial electronic device today is the Modbus. Now we will discuss what is Modbus communication protocol and type of the Modbus communication protocols used in the industry. The Modbus communication protocol is the oldest communication protocol as far the most popular automation protocol in the field process of the automation is known as the Modbus protocol. That is also support the SCADA, supervisory control and data acquisition. Not only this, I mean, after knowing how to create Modbus based networks is essential for any electrical technician or an engineer working in this occupation fields. And being able to integrate devices from different manufacturers is a skill that is in demand and will ultimately make you more valuable and marketable in the industry. Modbus is a communication protocol published first by the Modicon in 1979. And for use, it can also use with the PLC. Modicon is now owned by the Schneider Electric, and Modicon provides common language for devices and equipments to communicate with one another. For example, Modbus enables device on a system that measures temperature and humidity connected with the same network. For example, here you want to measure the humidity or the temperature. So you can easily do it because this is a kind of this Modbus enables the device on a system that measures temperature and the humidity connected on the same network to communicate the result to a supervisory computer or PLC. Now come to the development and the update of the Modbus protocol have been managed by the Modbus organization. The Modbus organization is an association of users and suppliers of Modbus compliant devices. The several versions of the Modbus protocol exist for the serial port and Ethernet, and most common Modbus protocols are Modbus Plus, Modbus ASCII, Modbus RTU, Modbus TCP, etc. Modbus publish the Modbus communication interfaces for a multiple drop network based on master and slave architecture. Communication between the Modbus nodes, so these are the nodes, is achieved with send request and read response type messages. Modbus is an open standard that describes the messaging communication dialogue. Modbus communicates over several types of physical media such as RS-232, RS-485, RS-422 and over Ethernet. The physical media will be selected at the time when you purchase the devices. The original Modbus, the very first Modbus interface run on RS-232 serial communication, but most of the latter Modbus implementation use Modbus RS-485 communication, because it allowed longer distances, high speed, and the possibility of multiple devices on a single multi-drop network. So one simple interface like RS485 and RS232, the Modbus messages are sent in plain form in plain form. This is simple plain form over the network, and the network will be dedicated to only Modbus communication. So this network is only for the Modbus communication. However, if your network requires multiple heterogeneous devices using a more versatile network system like TCP/IP over Ethernet, the Modbus messages are embedded in Ethernet packets with the format prescribed for these physical interfaces. So in this case, Modbus and other types of mixed protocol can coexist at the same physical interface and at the same time. That is the beauty and the benefit for the Modbus communications. So if you come to the Modbus, message structure. So this Modbus message structure is mainly based on the point-to-point or the peer-to-peer protocols and peer-to-peer network. Modbus is able to function on both point-to-point and multi-drop networks also. Okay, so this may support point-to-point as well as multi-drop networks. Now once again come to the Modbus architecture, the communication architecture. Modbus devices communicate using master slave, or sometimes is also called as a client server for Ethernet. So this is the main architecture for the Modbus device communication. Here only one device can initiate transaction, that is also sometimes called the queries, and other device respond by supplying the requested data to the master. For example, here you can see this is the master and these are the slave. So master will request their data or queries, slave will answer that query. A slave in this peripheral, there may be some flow controller, there may be some motor, there may be some temperature sensors, and many more. So slave is a peripheral device such as I/O transducer, valve, networking drive, or sensor, or any other measuring type of device which processes information and sends it response messages to master using Modbus. Master can address individual slaves or initiate a broadcast message to all slaves. Then slaves return a responses to all queries addressed to them individually, but do not respond to broadcast messages. That is the limitation of the slaves, or that is the protocol for this Modbus communication. Not only this, slaves do not initiate messages on their own and only respond to queries transmitted from the master. The master's query will consist of slave address, or sometimes called it as a broadcast address, a function code with a real read and write data command to the slave, along with the CRC error check. The error checking is a value the master or slave creates at the beginning of the transmission and then checked when the message is received to verify the contents are correct. A slave's response consists of fields confirming it received the request, the data to be returned, or an error checking data. If no error occurs, the slave's response contained the data as requested. If errors occurs, the message query received by the slave, or if the slave is unable to perform the action requested, the slave will return an exception message as its response. So you can understand that this CRC field will give you either data or the exception message. In addition, the error check field of slave's message frame allows the master to confirm that the contents of the message are valid or not. So this is all about the Modbus. Now we will move forward towards the Profibus. So let's get started. So this is a factory floor. You can see in this typical factory, you have two key areas. One is factory floor and another is the control room. And this control room, it has several industrial computers. And this factory floor, you will find number of sensors and actuators. One of the most common industrial computer you will see in the control rooms is the PLC or the programmable logic control. The PLC job is to control the process of the manufacturing and not only and the end of the end product of the factory. A PLC does that by monitoring the sensor. The sensor, which measures condition like pressure, temperature and levels, can be found anywhere along the manufacturing line on the factory floor. And those sensors can be located quite a distance from the control room. For example, 1,000 feet. So how do you ensure a PLC could successfully monitor all those factory sensors? Well, you could use able to connect each PLC input and output directly to the sensor. But here is the problem. In large factory, there is often long distance between the control room where the PLC is installed and the factory floor where the sensors are installed. Doing in that way, you are going to end up with massive number of cables running between the control room and the factory floor. So you can understand that this is not only very expensive, it is also very inefficient. The better way from that kind of problem, the solution is the Profibus DP. So by using the Profibus DP, you can decrease your cable length. Let's see how. The Profibus DP allows you to move the PLC input and outputs to the factory floor. So from here, the control room, you are down, the PLC output input is at your factory floor. And you can connect them to the sensor. You can connect the IOs or to PLC using this single RS485 cables. Then use shorter cables to connect IOs to the sensor. And then use the single cables to connect the same IOs to PLC or you have any other supervisory control system. So therefore the setup is far cheaper and much more efficient. In this Profibus DP, the DP stands for the decentralized peripheral. Before Profibus DP, the I/O or the peripherals were centralized in a control room. Okay, but by the moving them into the factory floor next to the central, we decentralize these I/Os or peripherals. Hence, the DP designation. So that's why we call the type of this type of Profibus as a Profibus DP. But sometimes after Profibus DP installed or developed, a creative bunch of automation engineer had an idea. What if we could get rid of the cables as well and make this network even more efficient? And that's how Profibus PA invented. PA stands for Process Automation. Profibus PA allows you to remove this IO unit, whatever here for the Profibus PA is Profibus DP, and also the cables. I mean, in Profibus DP, there is lesser amount of cables is used than that of the Profibus DP, and it also allows you to remove the IO unit and replace them with a segment coupler and a single Profibus PA cable. See, this is a single cable. With this new setup, instead of connecting the sensor to the I/O one by one, you can connect all of them to a single Profibus PA bus. On the other side of this bus, one segment coupler works to convert the Profibus PA signal to the Profibus DP signal. Okay, so that is connected to the sensor. So therefore, you can have an even more economical and more efficient network structure. Now you may be asking, why do I need this segment coupler or converter here? Because I can't just connect Profibus PA directly to the PLC. So you may ask that why this segment coupler is used, or can I connect this sensor to the directly to the PLC? The short answer is no. Why? Because the PLC doesn't have a Profibus PA port on it. But the good news is the most PLC have the Profibus DP port. So by utilizing this segment coupler or converter, you can use Profibus PA in the old system as well. By doing this, you actually end up with a Profibus PA before the converter. So this part is Profibus PA, fine, and Profibus DP after the segment coupler. So if I try to summarize how to industrial communication, how this two industrial communication protocols have changed the automation industry, and that is increase the efficiency of the setting up the PLC controls. With the invention of this Profibus DP, we are able to advance from having the PLC in the control room directly connected to the sensor on the factory floor, and then we decentralize the IOs and moving them next to the sensors, and then using simple RS485 cables we can connect the IOs to PLC. Then with the help of Profibus PA, we made the network more efficient by reducing the cable length. Not only this, Profibus and the Profinet are industrial communications protocols that is used extensively by the Siemens control systems. While they may sound familiar, now coming to the difference between Profibus and the Profinet, let's look at this protocol first. Then I will tell you what is the difference between the Profibus and the Profinet. Profinet. Okay, let's, as I told you, Profibus is it is released on 1993. It is also told, known as the process field bus. Is a kind of industrial communication protocol. And the fact is that at the end of 2020, 70 million devices are installed with the basis of these Profibus protocols. And not only this, it is well-established technology used in many different control applications. A Profibus communication port may look very similar to you. So this is the Profibus communication port. It looks like a standard DB9 serial connector. And most of the Profibus cable looks like this. It is easily recognizable by purple jacket. So I'll come to the how this looks like. The practical example of this. If I consider some other Profibus connector, they also have a pass-through port on the back of the connector. Now, you have now note that both kind of connectors have a red switch. So if I come to this part, so you can see there is a red switch on the back. This switch controls the terminating registers. The terminating registers indicates the end of Profibus networks. This switch must be set on position on the last device and off every other devices. If these switches are set incorrectly, the bus fault will occur. Each devices on this Profibus network must have unique address ranging from 1 to 127. That means that up to 127 devices may reside on a single Profibus network. For some devices, the address will be setting step 7 or TIA portal, that is a software interface. For others, the addresses must be configured using deep switches located on front of the devices. This is a very technical term. Now, the Profibus networks operate at speed of 9600 bits per second to 12 megabyte per second. While Profibus cable may be range from 50 meters to 1000 meters long. But you have to note that shorter cable lengths are required for higher data rates. On the other hand, Profinet is a newer Ethernet-based Ethernet-based industrial communication protocol. Here, the physical interface used for Profinet, which is standard RJ Ethernet jack. Profinet cable can be easily identified by this green color, while in some cases a standard Ethernet cable may be used to connect to Profinet devices. In general, Profinet cables should be used as they contain robust shielding. You can see that in these images, and they are designed to function well in harsh industrial environments. The Profinet works 100 megabytes second, and cable distance may be up to 100 meter in length. Due to its high-speed operation and response time of less than 1 millisecond, Profinet is ideal for high-speed industrial application. And the cost therefore is higher than that of the Profibus. Because Profinet uses the same physical communication standard as Ethernet, so standard Ethernet switches can be used to expand your network. So you can easily understand that how the versatile is the Profinet. Profinet devices use three different type of addresses like IP addresses, MAC addresses, and device name. And all Ethernet devices use IP address and the MAC addresses, but the device name is unique for the Profinet devices. As an automation engineer, you will be primarily concerned with device names and the IP addresses. As you configure your, if you want to configure your Profinet networks. Due to the higher speed and the great flexibility, Profinet is becoming a preferred communication protocol for all industrial applications nowadays. So both of these Profinet and Profibus protocols are widely used today, and being familiar with them and both of them will essential to you for the upgradation yourself as a control engineer. Next day we will start with the device net. So let me show you some real life example or the case studies of the Profibus and some live demonstration how the Profibus can be integrated and what are the specifications of the cable. So let's start with that.
Of how to connect an industrial Welcome to this demo video of how to connect an industrial sensor to a PLC and a cloud in parallel. For this setup, we have a temperature sensor coming from IFM, which is connected via I/O link to this I/O link master, also from IFM. The I/O link master is connected via Profinet to a Siemens PLC. So actually, this is quite a typical setup which you can see in the industry. What we want to do now is we want to connect this temperature sensor, or basically get data from this temperature sensor and send it directly to AWS IoT Core without affecting this production system, so without touching the Siemens PLC. We will of course use the Cloudtrail box and as well the dedicated IoT port from that IFM I/O link master. So let's connect the IoT port of that I/O link master to the Cloudtrail box. That's everything you need to do. No more configuration here. So let's jump into the configuration screen of Cloudtrail. This is Cloudtrail's device management cloud, basically the place where you configure all your boxes. And this is actually the Cloudtrail box, which we've just connected to the demo setup. So I just selected, click on new connection, and what I instantly see is that the box automatically found this IFM I/O link master, as well as the temperature sensor, which is connected to port 1. So what I do now is I select the temperature sensor, click on next. This is Cloudtrail's device management cloud, basically the place where you configure all your boxes. And this is actually the Cloudtrail box, which we've just connected to the demo setup. So I just selected, click on new connection, and what I instantly see is that the box automatically found this IFM I/O link master, as well as the temperature sensor, which is connected to port 1. So what I do now is I select the temperature sensor, click on next. Here I tell the device how often to send the data to the cloud. So for instance, every 500 milliseconds, click on next. And on this screen, I can choose what cloud platform I want to connect to, or I can also choose a local MQTT broker. But for this demo setup, we're going to use AWS. And the next step, I give the device a name. So let's just call it temp for temperature and click on create. That takes a little. What we do in the background is we automatically add this device to AWS, retrieve all the credentials, configure the MQTT client, basically everything done automatically in the background. What you get here is a little documentation of how the data is structured and of course the MQTT topic. So let's just copy that, jump into AWS, into the AWS account, and there's a little test function, and I can just paste in my MQTT topic, click on subscribe, and then already see how the data is coming in here. So what I'm doing now is actually touch the sensor, and we instantly see how the temperature is rising here. So let's jump back to the overview. What we did in this video is we now connected this temperature sensor directly to AWS IoT Core, and all that without ever touching the Siemens PLC, no configuration, no changes to the production system. It's a real wide path, get data in parallel and all through the Cloudtrail box. Thanks for watching.
Simple networking within the CLV6 series thanks to integrated SIG. For three-side reading, various laser scanners from the CLV6 series can be interconnected via a SIG CAN network. To start read mode, the master scanner sends out a trigger signal to all interconnected scanners. The CLV650 with integrated autofocus function is used for reading from above. The autofocus function automatically adjusts to the varying object height so that it can reliably decode barcodes at different reading distances. The CLV615 laser scanner is generally used for side reading. Once the reading process is complete, the master scanner collates the results from the individual readers and sends this data to the second generation CDF600 Profibus gateway. The combined read result is then sent to the PLC via Profibus protocol. Simple networking within the CLV6 series thanks to integrated SICK CAN network. The compact design enables installation even in applications with limited space. The minimum lateral overhang of the scanner reduces the risk of mechanical damage. Reading regardless of height, thanks to autofocus with integrated distance measurement. Sophisticated two-screw system for fast, flexible mounting on all standard profiles.
Programming needs. We offer I/O or any. When you're going to connect your PLC to remote I/O or any other device in the field using the Profibus network, you need to make use of an RS485 or a Profibus cable. But to be able to connect the cable to the PLC or any other device on each end of the network, you first need to connect the cable to a Profibus connector. In this video, I'm going to show you how easy it is to do that. Here, I have a Profibus cable and a Profibus connector. We ordered this cable from Siemens, and if you're wondering about the order number, this is the order number that you can use to order the same cable if you need to use that in your project. Just Google the order number, and the link for the Siemens site pops up in the first few results. Now, this is the product information for the cable I'm currently using in this video. As you know, cables are sold by the length. As you can see here, with this order number, the length for the cable you receive will be 200 meters, which is about 650 feet. So if you need a different cable length for your project, you may want to consider a different order number when placing your order. Now, where can you find the order numbers for different lengths of this cable? For that, you can click on this link here on the top of the page, which says Profibus Bus Cables. Here in this page, you can see a list of order numbers for the same cable, but with different lengths. For instance, with this order number, the cable length will be 20 meters, which is about 65 feet. Or with this order number, the length for the Profibus cable will be 50 meters, or 160 feet. So depending on the project requirements, you can select a different order number when placing your order. I'm also holding a Profibus connector in my hand. This is the order number for this connector. Just as you did for the cable, you can Google this order number if you want more info on this module. We will put a link below this video to the Siemens website for both the cable and the connector. Now, let's see how you can connect the cable to the connector. Here, we have a Profibus cable that we're going to connect to our DB9 Profibus connector. The items that I'm using for this task are a DB9 Profibus connector, a Profibus cable, a utility knife, a screwdriver, and diagonal pliers or wire cutters. The Profibus cable is a shielded twisted pair. We describe the outside as the outer sheath, followed by a braided shield, a foil shield, an inner sheath, and two single-core wires, one green and one red. The first thing that I need to do is to strip the outer sheath or the purple plastic outer cover. I'll measure about 2 inches of cable, which is approximately 2/3 the length of my index finger. I'll begin stripping the outer sheath by carefully scoring the plastic with a utility knife. Under ideal circumstances, I would use a Profibus Fast Connect stripping tool to strip the Profibus cable. But in a pinch, I'm using a utility knife. You may use that or any other appropriate tool that you may have available. I'll cut around the entire sheath, being careful not to cut too deep into the cable, and continue scoring the plastic until I've cut entirely through the sheath. Now that I've cut around the outer sheath completely, I need to make a cut from the scored area to the end of the cable. Once I think that I've cut through, I'm going to try to remove the outer sheath. If you're unable to remove it, go back and continue to cut until you can successfully remove the outer sheath to expose the next layer of cabling, which is the braided shield. In order to remove this layer, I'll use the wire cutters and begin clipping the braid at the cut end. Once a small section of the braid has been clipped, it may be easier to gather the remaining braid to clip it near the stripped end piece. Continue to clip the braid all the way around the cable until you've removed as much of the exposed braid as possible. Once the braided shield has been removed, I'll use the utility knife to score the foil shield to remove it. The foil is fairly easy to remove and won't require much effort. Once the foil is removed, you'll see the inner sheath that is fairly rigid. I'll use the same technique that I used while removing the outer sheath. Once I've completed the cut, I'll remove the inner sheath to expose the wires. As described previously, here we have two single-core wires, one green and one red. Separate the wires slightly in preparation for placing them into the Profibus connector. I'll open the connector, and you'll see that the internals consist of two cable connection paths. Above the cable opening holes in the bottom of the connector, you'll see two plastic tabs. These tabs, when pressed closed, will pierce the wire sheaths as well as hold them in place. While the connector is held with the cable holes at the bottom, I gently lift the plastic tab on the left to expose the wiring mechanism, which will hold both of the wires. Once the cable is properly routed, I'll close the connector and make sure that there is no interference caused by the cable. I secure the connector closed with the embedded screw and my screwdriver. Make sure you don't tighten the screw too much, as this may break the connector. Well, that's it. That's all there is to making a Profibus connection. If you found value,
Okay, so I think you found interesting things in these videos. So it's all about our today's class. If you have any queries, you can ask. Otherwise, we will meet again on Friday, this Friday, as scheduled during the scheduled class. Okay, so fine. Goodbye to all.
on this